Hello, welcome everyone to lecture number 10 of Fundamentals of Computing, which is on binary number system. This is in continuation to my previous lecture, that is the lecture number 9. The topics that I am going to cover in this lecture are conversion of decimal fraction to binary fraction, subtracting two binary numbers, subtracting two binary numbers using 2's complement, multiplying two binary numbers and dividing two binary numbers. So, let us start with the first one, that is the conversion of decimal fraction to binary fraction. We use the technique of successive multiplication by 2 in conversion of decimal fraction to binary fraction. The integer part is noted down after multiplication by 2 at each stage, and the remainder new fraction is used for multiplication by 2 at the next stage. This process repeats till we get the 0. So, let us start with one of the example for better understanding of this method. Here I have taken a decimal fraction which is 0.8125. So, according to the method, first we have to multiply it by 2. Here I get 1.6250. From this, I will take 0.625 as a remainder new fraction, and this one is noted over here as the MSV. Then in the next step, again this 0.625 will be taken, which will be multiplied by 2. Then 1 is stored over here and the decimal part is stored in the remainder new fraction. This 0.250 is again multiplied by 2, we obtain 0.50. Here the 0 is stored as an integer and we take 0.5 as a remainder new fraction. Then 0.5 is again multiplied by 2. So, here we get what? 0.0. Now, 0.0 means what? Here you have to stop. No further multiplication is required. This one is getting stored over here. So, the binary representation of 0.8125 will be 0.1101. So, this is the method for the conversion of decimal fraction to binary fraction. Let us take another example to find the binary conversion of 0.635. So, here the fraction is 0.635. We multiplied it by 2. Now, we obtain 1.270. This one is stored over here, and then this 0.270 will be taken for the next step, which is multiplied by 2 again. Then here it is 0, which will be stored over here, and the new remainder fraction will be 0.54, which will be again multiplied by 2. We obtain 1.08. This 1 will be stored over here, and the new remainder fraction will be 0.08, which will be again multiplied by 2, because here we have to get 0. When we get a 0 over here, then we have to stop. So, here it is what? It is again it is a 0. So, we put what? The 0 here. Then take 0.16 multiplied by 2. The 0 is going to be stored over here. This 0.32 is again multiplied by 2. The 0 gets stored over here, and then we get the 0.64, which has to be multiplied again by 2. So, in this case we get the 1. So, 1 will be here, then again 0.28. This process repeats because we did not get the 0 over here, but we have to stop somewhere. So, we take the approximation. So, approximation means what? Here we have taken only this 7 multiplications only for the conversion of binary 0.635 for getting the binary representation of decimal 0.635. So, according to that it will be 0.1010001, which is the binary equivalent of 0.635. Here you can see, although here we won't get the 0, but you have to stop somewhere. So, this is the approximation binary representation. Okay. So, next is subtracting two binary numbers. There are some rules that has to be followed for binary subtraction. What it says? 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0. But in the case of 0 minus 1, here you have to borrow 1 and this 1 will be taken. This 1 is borrowed from the next more significant bit. So, let us take an example, 14 minus 5. First you should have what the decimal 14, so convert it into the binary. So, it will be 2 7s are 14, remainder is 0, 2 3s are 6, remainder is 1, 2 1s are 2, remainder is 1, 2 zeros are 1, so remainder is 1. We have to take it in this way. So, the binary representation of 14 will be 1 1 1 0. This is the binary representation of 14. In the same way, find the binary representation of 5. So, 2 2s are 4, remainder is 1, 2 1s are 2, remainder is 0, 2 zeros are 0, so remainder is 1. So, this will be represented as what? 1 0 1. This is what? 5. So, this bit will by default taken as 0, 0. So, we have to do what? What is 14 minus 5? So, subtract it according to the rule. Now, here the first one is 0 minus 1. In the case of 0 minus 1, you have to what? Borrow 1 to this. So, it becomes what? 1. It becomes 0. So, 0 minus 0 is 0. Then 1 minus 1 is 0. 1 minus 0 is 1. So, this is the number that you get after subtracting this 5 from 14. So, what is its decimal equivalent? This represents at 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus 0 into 2 to the power 2 plus 1 into 2 to the power 3. That comes out to be 1 plus 0 plus 0 plus 8, that is equals to 9. Yes, 14 minus 5 is 9, which is the answer. So, in this way we will do the binary subtraction. Let us take another example for the subtraction. First get the binary representation of 10. We have to follow the same steps. 2 5s are 10, remainder is 0. 2 2s are 4, remainder is 1. 2 1s are 2, so remainder is 0. 2 zeros are 0, remainder is 1. So, binary representation of 10 will be what here? It is 1 0 1 0. You have to subtract what? 5. We already know its binary representation is 0 1 0 1. So, subtract it. Here you have to borrow because this one is 0 minus 1. So, this becomes 0. Again here you have to borrow. So, this becomes what? Your 1 and this becomes 0. So, this is the result. What is it? This represents in decimal. It is 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus 1 into 2 to the power 2 plus 0 into 2 to the power 3. So that comes out to be what, your 1 plus 4, which is equals to 5. Yes, 10 minus 5 is equals to 5. This is the answer. So by this is for when we subtracting the smaller number from the larger number. This method is for this type of subtraction. Now take another example. Here we are subtracting a larger number from the smaller number. So binary representation of 5 is that we already obtained, it's 0, 1, 0, 1. So it is what? 0, 1, 0, 1. Binary representation of 7 will be, you can find it out, 2 3s are 6, 1, 2 1s are 2, 1, 2 zeros are this, and remainder is 1. So this becomes what? 1, 1, 1. We have considered the 4 bits, so it is written in this way. 1 minus 1, obviously it is what? It's a 0. Then here you have to borrow, then again this becomes what, your 0, you have to borrow. So this becomes what, your 1, and you have to borrow it from here. So this becomes what? 1 1 0. Now this, since it is what, you are subtracting a larger value from the smaller one. This is the case. So in this case you have to take what? The 2's complement of the result. So what is the 2's complement? 2's complement is nothing but this is equals to 1's complement plus 1. 1's complement is nothing but, if it is 0 then that will be replaced by 1, if it is 1 then that bit is replaced by 0. So it's 1's complement, this becomes what, your, it becomes 0 0 0 1. Yeah, because this is 1, this becomes 0, this is 1, this becomes 0, this is 1, this becomes 0, and this is 0, so it becomes 1. Then add 1 into it, so you get what? 1 plus 1, this is 0, carry 1 0 0. So this will be the answer. What is a decimal? It is obviously 2 to the power 1, that is equals to 2. Yes, this is the answer with the negative sign. So minus 2 is the answer. Let us take another example, 7 minus 8. This binary representation of 7 is, we have already seen, 0 1 1. So binary representation of 8 is 1 0 0 0. Why? Because simply from here you get what? 2 to the power 3, which is equals to 8. Now you have to subtract it. So 1 1 1 1. Okay. Then find out what? It's 1's complement. So this becomes what, your 0 0 0 0. Then find out the 2's complement, which is nothing but 1's complement plus 1, and that becomes 0 0 0 1. This is the answer. So yes, 7 minus 8 is nothing but minus 1. So in this way we do the subtraction in both the cases when we are subtracting larger from the smaller or from smaller from the larger. There is another method of subtraction. Here we use 2's complement. So what this method says, step 1 says first find the 2's complement of the number to be subtracted. We have already seen how the 2's complement is calculated. Find the 1's complement of number. 1's complement means what? Convert 0 to 1, or if it is 1 then that will be converted to 0. After that add 1 to the resultant number in 1's complement to get the corresponding 2's complement. So first step says what? Find the 2's complement of the number that you want to subtract. Then in the next step, add the minuend and subtrahend in 2's complement, which is obtained in step 1. Then in step 3, you have to check if there is a carry, then ignore it from the sum to obtain the result. Otherwise, recomplement the sum and attach the negative sign to get the result. So this is the method. For better understanding, let's take an example. It's 18 minus 35. So what is the binary representation of 18? That I have already calculated. You can check out your own. It is what? 1, 0, sorry. It is 0, 1, 0, 0, 1, 0. This is the binary representation of 18. Binary representation of 35 is 1, 0, 0, 0, 1, 1. So we have to do what? By using 2's complements, first step is what? You have to find the 2's complement of 35. So for 2's complement, we have to find the 1's complement and then add the 1. So 1's complement becomes what? Replace 0 by 1 and 1 by 0. So this becomes 0, this becomes 1, this becomes 1, this becomes 1, this becomes 0 and this becomes 0 plus 1. So it becomes what? Your 0, 1, 1, 1, 0, 1. This is the 2's complement of 35. Then the next step says add what? This 18 with 35. So 18 was your 0, 1, 0, 0, 1, 0. So you have to add this. On adding, you get what? This is 1, this is 1, this is 1, this is 1, this is 1. So here there is no carry. So rule 3, or you can say step 3 of the method says you have to find the complement of the result. So its complement becomes what? Your 0, 1, 0, 0, 0, 0. So this is the 1's complement. So 2's complement becomes what? Add 1 over here. So you get what? 0, 1, 1, 2, 3, 0 and then 1. This is the final result. So let's see, just find its decimal equivalent. So 1 into 2 to the power 1 plus, I have ignored this, 1, 2, 3, 4 and 5. Rest of them becomes 0. So only we have 1 into 2 to the power 1 plus 1 into 2 to the power 4. That is equals to what? 1. Sorry. This is what? 1 into 2 to the power 0. So this becomes what? 1 plus 16. That comes out to be 17. Yes, 18 minus 35 is what? Your 17, which is the answer. Let's do the second example for better understanding of this. Here binary number is there given to you. It is 1, 0, 1, 0, 1. You have to subtract what? This. So first find what? Its 2's complement. So its 2's complement becomes 1's complement, that is 1, 0, 0, 0, 1 plus 1, that becomes what? Your 1 plus 1, 0, carry 1, 0, 0, 1. So this is what? Your 1, 0, 0, 1, 0. So add it, 1, 0, 0, 1, 0. This way you get what? 1, 1, 0, 1, 1, 0. Here you obtain what? The carry. In the case of a carry, if it is a carry, then what you have to do? You have to ignore this carry. Result will be only this part, that is 0, 0, 1, 1, 1. What is this represents? This represents the result which is obtained after the subtracting 0, 1, 1, 0 from 1, 0, 1, 0, 1. So, this is the method which is used to subtract two binary numbers by using 2's complement. Next, I will discuss the multiplication of a binary number. Multiplication of a binary number is done by using the following rules. It is 0 into 0 is equals to 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1, same as the case of your decimal number system. So, let us take an example to do this. Suppose you have to multiply what? 1 0 1 0 by 1 1. So, this 1 0 1 0, it represents your, say, find it out, its decimal equivalent. It is, why I am doing it? Just to cross check it whether I am doing correctly or not. So, it is what? 0 1 2 3. It means what? 2 to the power 3 plus 2 to the power 1, that is 8 plus 2 is equals to what? Your 10. And this 1 1, this is 2 to the power 0 plus 2 to the power 1, that is equals to 3. So, how it will done? 1 is multiplied by what? This. When 1 is multiplied by 0, we get 0. When 1 is multiplied by 1, you get 1. When 1 is multiplied by 0, you get the 0. When 1 is multiplied by 1, you get the 1. In the next step, again this 0 comes. After that, 1 is multiplied by this 0, you get the 0. 1 multiplied by 1, you get the 1. 1 multiplied by 0, you get the 0. 1 multiplied by 1, you get this. And then add this. So, after adding, you get what? This is 1 1 1 1 0. So, this 1 1 1 0, this is equivalent to what? 0 1 2 3 4. It means 2 to the power 4 plus 2 to the power 3 plus 2 to the power 2 plus 2 to the power 1, that is 16 plus 8 plus 4 plus 2, which comes out to be 30. Yes, it is correct, because 10 multiplied by 3 is nothing but that is equals to 30. So, in this way you can cross check it also whether it is the multiplication that you have done is correct or not. Next, we will discuss on the division of two binary numbers. So, what the rule says? The rule is same as that of we consider in the case of decimal number system. So, here I have taken an example where we divide 1011 by 11. So, first is 0, then 0, result will be 1, then we take the 0 from here, then again 0, so result will be 10, then again we take what? This 0 over here, then 1, so divided by, subtract this. After subtracting, you get what? This 1 1, then again 1, so you get a 1 and the answer will be 0. So, this method is same as that of your decimal number. So, here it is 1 1 represents what? Your, this represents 3 and 1 0 0 1, this represents what? Your 9. This is the decimal representation of this. Obviously, 3 3s are 9. So, this one will be 3. So, we get the result which is 0 0 1 1, its decimal representation is what? 1 into 2 to the power 0 plus 1 into 2 to the power 1, rest is 0. So, this is equals to 3. Yes, our answer is correct. Next is representation of signed and unsigned numbers. In case of binary numbers, we use 0 in the MSB to indicate that it's a positive sign, and 1 is put in the MSB to indicate that it's a negative sign. So, the three different ways to represent a negative binary number is when we use a sign magnitude representation, binary equivalent of 9 is 1001. Since it is minus, so we put the 1 over here in the MSB. In the case of sign 1's complement representation, we take the complement of this 9. So, this becomes what? 0, 1, 1, 0, and since it's a negative, so 1 will be kept over here. In the case of 2's complement, first find the 2's complement of this 9, which is what? 0, 1, 1, 1, and since it's a negative, so we put a 1 over here. So, these are the three ways to represent a negative binary numbers. Another one is the binary coded decimal that we call as the BCD codes. This is different from your binary equivalents because here in each decimal number is represented by 4 binary bits. So, 3 will be represented as 001, means 4 bits are required to represent a decimal 3 in the case of BCD. Similarly, 56 will be represented as 5 here and 6 for this, 4 bits for 5 and 4 bits for 6 in BCD. So, from here you can make out the difference. If we take a decimal 43, its binary representation is 101011, where the BCD is what? Consider this 4 bits, this represents a 4, and consider next 4 bits, this represents a 3. So, this is the difference between the binary coded decimal and the equivalent binary numbers, or you can say binary equivalents. So, this was all about the binary number system. Hope you understand it, because I have given so many examples to make it easy to understand. Thank you.